news. This just in at ATCG News. The first gene-edited babies using CRISPR technology were born this month due to the work of biophysicist Dr. He Jiankui. What does this event signify for the future of human genome editing? What does this really mean for society? To answer these important questions, we will go over to my colleague Bill Bates, who is with molecular geneticist Dr. Jimmy Watts. Bill?
Hey Ruth, I'm here right now with Dr. Jimmy Watts, and we're going to ask him a few questions to try to get some clarification for the public. But first, we took to the streets and interviewed some random citizens about human genetic engineering to see what they really know. These are the answers we received.
You go first.
Just like altering or editing like the way people are, their genes and the way people act.
I feel like it's something to do with special needs, like helping with retardation and things like that.
I think it's like when you pick like how your baby wants to be or something like that.
Yeah, just like modifying maybe like mutations and stuff like that or something like that.
Cyborgs.
I was gonna say like test tube babies, like science babies.
So Dr. Watts, in response to these statements from the public, can you give us an explanation of what human genome editing actually is?
Sure, Bill. First of all, thank you for having me. It's great to be here. I hope I can offer some clarity for the public and those who aren't exactly sure what to make of these huge strides in the scientific community. So I'd like to start this discussion by saying this. Human genetic engineering does not create cyborgs. Human genetic engineering involves the manipulation of the human genome using molecular genetic techniques such as CRISPR, which is currently the most user-friendly genome editing technology. Now, the human genome is the complete set of human DNA, and everyone has variations in their genome, which can sometimes be advantageous and sometimes be detrimental. This is often the case for people that have mutations in their DNA which lead to genetic disease. In these instances, the human genome editing could be a practical and potential cure to these diseases. CRISPR technology allows us to program a protein which will pinpoint a specific location on the DNA, latch on, and replace the section with whatever new DNA we want to insert.
I don't think you should be able to like get rid of all diseases and everything. Like I've watched the 60 Minutes where like people are like finding ways to get rid of like all diseases. Like you can like look at the baby and be able to tell if it'll have like if it'll ever get chickenpox or if it'll.
Why do you think that's wrong, to get rid of all diseases?
It's cheating.
It's cheating? It's cheating, right?
Yeah, that's messed up.
But then like you get people who could like have superpowers or some shit. Like that's awesome.
I think it's a good alternative for some people who are like infertile and stuff like that, but you also fall into creating like a perfect human being, which a lot of people don't agree with because not everyone has the money or the access to this technology.
Yeah, and like no one's gonna be perfect. Like that's like what makes life. People you interact with people who are different. Like if you're all the same, then what's the point? You're all just like robots.
I think it kind of depends on, kind of as what Kylan harped on with like the special needs. If genes can be edited to help people, then I think it's morally like credible, but otherwise probably not.
I'm gonna go off what he said. I think if it's making a positive effect on humans, then it should happen, but if it's like military associated and it's just like enhancing, just to enhance, then I think that should not be allowed.
To cure cancer, I'm for it, but then to like do other stuff, like build army of cloning yourself. I mean, no, then that's wild.
So tell us, Jimmy, what should be considered morally, ethically, and practically when it comes to genetic engineering?
Absolutely, Bill. That's a great question, and I thank you for it. When it comes to morals and ethics, each person is going to have their own point of view and opinions. However, regardless of that, it's going to be important for us to consider the factors that will affect the rest of society as well. So, some of the ethical concerns for this topic are how and if the technology should be regulated, whether or not it should be legal at all, and then whether or not technology like this should be used in a way that aims to enhance as opposed to simply treat. Moreover, the idea of altering the natural process of human life may infringe on different moral values, specifically religious beliefs of many groups. Plus, it doesn't take a geneticist to see the socioeconomic effect that this could have. When only the rich are able to afford this sort of treatment, the rich get richer while the poor fall even further behind. And the social class gap could widen in ways that we've never imagined before.
Height, intelligence, and looks, I guess.
Speed, good body, and intelligence.
I think prevention/treatment. I think enhancement is a little unethical just because it's not like fair. Oh, I hate going into this, but like not everyone has like access to it, and it's not something that's gonna be like presented to every family.
Be taller and
Height, shoe size.
stronger.
Why
Yeah,
shoe
pretty
size?
much.
Big feet.
I wish I never had asthma.
So, what are we currently capable of when it comes to the field of genetic engineering, Dr. Watts?
Well, Bill, while we may not have very solidified uses for this technology in the treatment of disease yet, scientists are more than capable of performing these type of technological advances on human embryos. At the Oregon Health and Science University, for example, scientists were able to correct a mutation for hypertrophic cardiomyopathy in most cases, about 75% of the time. We're only beginning to see the potential of this CRISPR-Cas9 technology really at this point.
Thank you, Dr. Watts. So, to close our discussion today, what does this advancement indicate, and what should the public expect following this news?
I'm glad you asked that, Bill. I really am. Thank you. You asked good questions.
Thank you. You answered them well.
So this research is a very big step for something scientists have been working on for quite some time. Dr. Xu was able to alter the genome of these twin girls in order to make them resistant to HIV, despite the fact that their father carried the HIV virus. However, most accepted uses of this technology involve doing genetic editing on somatic cells, the cells that make up the body, not sperm cells or egg cells, which are known as germline cells. So what Dr. Xu did was perform human germline editing in order to produce these children, which is very controversial and has strict regulations in most parts of the world. Even in China, which has somewhat more lax regulations than most of Western civilization, including the US, this was a violation of regulations. And so not only is his research being denounced by China and the university that Dr. Xu worked for, but he's been suspended outright. So most countries don't allow the implantation of embryos that have been genetically modified, like it were in this case. And that's exactly what Dr. Xu did. So currently, policy does not support the use of gene editing technology in this way.
Thank you so much for your input, Dr. Watts. Now up next, trampolines, summer fun or silent killer? We'll be right back after the break. Hey Ruth, I'm here right now with Dr. Jimmy Watts. You went for it!
Action.
Oh shit, so... Damn, that was quick. Alright.
Yeah, it gets going.
Alright.
Genetic techniques such as CRISPR, and I've missed lines because it's going too fast. Ethical concerns for this topic and how and if... Fuck! I read it.
1. So tell us, Jimmy, what should we... Okay.
Wow, that was quick.
So what are we currently capable of?
Wow.
It's a good thing I don't have...